Good morning to all. In the last class you have seen the microwave absorption spectrum of a rigid rotor and the intensities of the spectral lines. In this class you will be studying the absorption spectrum of a non-rigid rotor. Now what is a non-rigid rotor? When a diatomic molecule is rotating, sometimes there will be a centrifugal stretching of the molecule, and due to this the rigid nature of the molecule is changed. Such molecule is called non-rigid rotor. The rotational energy levels for a non-rigid rotor can be written using Schrodinger wave equation as given here. Ej is equal to h square by 8 pi square I into j plus 1. This term corresponds to a rigid rotor, and due to the non-rigidity of the molecule, an additional term is included, which is minus h power 4 divided by 32 pi power 4 I square r square k into j plus 1 the whole square. Hence, we can write epsilon j as bj into j plus 1 minus dj square into j plus 1 the whole square. Here, b is the rotational constant as you have used in the previous class, and d is the centrifugal distortion constant, which is given as d is equal to h cube divided by 32 pi power 4 I square r square kc. From the definition of B and D, we can write D in terms of B as D is equal to 4B cube divided by omega bar square. Now, equation 2 applies for a simple harmonic force field due to the centrifugal stretching. If the force field is anharmonic, then epsilon j can be written as bj into j plus 1 due to the rigid rotation minus dg square into j plus 1 the whole square due to non-rigid rotation, which is simple harmonic, and the additional terms are due to the anharmonic motion. Hj cube into j plus 1 the whole cube plus k j power 4 into j plus 1 the whole power 4. Here h, k are small constants dependent on the geometry of the molecules, but they are negligible when compared with d. So usually we will be neglecting these two terms and we will be having terms with b and d only. For small j values, d is in the order of 10 power minus 3 centimeter inverse 1 and b is in the order of 10 centimeter inverse 1, and the correction term is negligible. But for j values of 10 or more, the correction term becomes appreciable. The selection rule is the same as in the case of a rigid rotor. Del j is equal to plus or minus 1. For any transition from j to j plus 1, we can write epsilon j plus 1 minus epsilon j is equal to nu j bar, and we can substitute for epsilon j and epsilon j plus 1 and rearrange the terms to get 2b into j plus 1 minus 4d into j plus 1 the whole cube. The first term is for the rigid rotor and the second term corresponds to the non-rigidity of the molecule. It is negative and the spectral lines are slightly decreased towards a lower frequency side. The displacement increases with j plus 1 the whole cube. The knowledge of D gives two useful information. It allows us to determine the value of G by fitting the observed spectrum with the above equation. So, if you have 3 consecutive lines from the observed spectrum, it gives unique values for B, D and J. It also enables us to determine the vibration frequency of a diatomic molecule given by omega bar square is equal to 4b cube divided by d. The force constant can also be directly obtained using the known formula for k, which is equal to 4 pi square c square omega bar square mu. Now, when we consider the energy levels and spectrum of a non-rigid rotor, this diagram gives a comparative study of the rotational energy levels and the spectrum of a rigid and non-rigid rotors. In the left hand side, we have the energy level diagram for rigid rotor, and in the right hand side we have the energy level diagram for non-rigid rotor. From the energy level diagram, we can see that for lower J values, the energy levels are not changed much. But for higher values of J, the energy levels are decreased for a non-rigid rotor. Now when you see the spectrum, since there is a decrease in the energy level, the spectral lines are shifted towards the lower wave number side in the case of a non-rigid rotor. So the effect of non-rigidity of the molecule is that the energy levels in the higher J values are slightly decreased and the spectral lines are shifted towards the lower wave number side. Thank you.